Hi everyone, my name is Tammy. I am the AEC lead here at Modern Design Centers in Durban. We are a business solutions company that specializes in the Autodesk products and applications in the AEC, manufacturing, and media entertainment space. Today, I'm going to chat to you about something that is quite personal to me and something I've in recent times become quite passionate about. So have you ever had that awkward and sometimes frightening moment where expectation and reality just don't meet up? You know, that moment where you perfectly predicted the way a situation was going to pan out, and when you walk into the room, you suddenly realize that this is not what you signed up for. And in some instances, it's a good thing because you get more than you expected, but oftentimes that panic and that discomfort comes from realizing that the reality is not quite what you have expected. So I want to start off with a little personal story about myself, because if you're somebody who can relate to the personality type profiles, if you're an Enneagram person, I'm a type 1. If you are a Myers-Briggs kind of person, I'm an INFJ. If you're just someone who reads personality types, I'm a self-confessed control freak. And I'm totally okay with that. But it essentially means I'm all about organizing, planning, controlling, and managing expectations and outcomes. It is very seldom that I like to walk into a situation and walk out of there feeling like I did not see that coming. I hate that feeling. I feel like life, especially in 2020 and 2021, has been so completely unpredictable that the little bit of predictability that we can muster absolutely is important to me. So if I get a task and I go into over-analysis mode, that is a completely normal thing for me. And truth be told, I drive my directors absolutely nuts with questions. I like to know where the boundaries are. I like to picture the situation in my mind. I need to know where I've got flexibility, what is the non-negotiables. And in recent times, I found myself in a position where I had to do a talk, or in this instance, it was an interview. And I remember the questions firing off like crazy. Where is this going to be? Where am I going to be sitting? Is there a stage? What is the venue? What microphone am I going to use? What am I going to talk about? Who am I going to interview? What is this person about? What questions do I ask? What does this person do for a living? How can I get into this person's head? What information can I get from them? Are there going to be lights? Are there going to be cameras? How many cameras are there going to be? And before you think that this woman probably needs therapy, and I probably do, I just want to bring it down to the fact that being able to predict the outcome of a situation gives me a sense of comfort. Knowing gives me a sense of comfort. It makes the situation more predictable, because if I can visualize in my head where I'm going to end up, I know how to take control of my situation. I know how to take control of my environment, and I know how to deliver the best I possibly can that is within my abilities. So in a sense, I feel a sense of control. I feel like I can do this. I feel like the task at hand is easy and manageable. Because there are a lot of items that I can't control, but the ones that I can control, I can try and use to my advantage to deliver in the best way possible. So what is the point of my story? Essentially, having data and information puts us in a much better position to make educated, calculated decisions going forward. It puts us in the position where we can safely predict, or near predict, I would say, what the outcomes could be than if we didn't have information or data to start off with. Information and data allows us to not assume, but it allows us to have concrete evidence on which to base decisions going forward. So what has this got to do with the fact that it's the new 3D? Well, nothing really. Essentially, it's a play on the fact that 3D used to be this amazing thing that we experienced, where we had this graphical information and we got to visualize and we got to communicate the design with clients, and we got to problem solve design issues. We got to do all these fantastic things because we actually got to see what our building looks like. And if you remember back in the day, there was, or maybe it's still the current situation in some instances, but there was the SketchUp to AutoCAD workflow and vice versa that was largely disconnected. But a lot of people started investing in SketchUp, specifically in a South African context, and I'm generalizing by saying that too. But this SketchUp to AutoCAD workflow used to be the thing that used to happen because it communicated so well to clients, and it was the thing that sold the concept to so many people, specifically those who couldn't visualize. It gave clients something to talk about. It gave external people something to talk about because they could understand and they could relate to it. Then came BIM. And BIM kind of changed things up a little bit because now we have the graphical information and the information inside the model elements as well. And if you think of traditional BIM, as you know it, probably, if you are exposed to BIM in any way, you may have heard some of these terms thrown around that you would see in the images at the moment. There's the BIM life cycle that starts with conceptual to detailed design, to analysis, to documentation, all the way through to operation and maintenance. Then there's the concept on which good BIM is found. So it's a 3D model, good technology, good processes, decent information, documentation, and all strung together in the common data environment. Then there's terms like 3D, 4D, 5D, 6D, and 7D BIM, all which gets put into this beautiful ecosystem that we call BIM. So what does this have to do with data? Okay, or where does data fit into this? So let's firstly have a look at what we define as data. So what is data? Data are individual facts, statistics, or items of information, often numeric, that are collected through observation. In the more technical sense, data are a set of values or of qualitative or quantitative variables about one or more persons or objects. So the thing about data, data is not information. Let's just clarify. Data forms the basis of information. It's not the information itself. A whole bunch of numbers in a page doesn't tell you anything unless a question is asked. And if we have to ask a question such as how many doors do we have in a building, the data will give us the answer for that. So data collected in the correct way and organized in the correct fashion gives us information. Information leads to knowledge. Knowledge leads to insight. And insight essentially leads to wisdom. But you cannot have wisdom without insight. You cannot have insight without knowledge. And you cannot have knowledge without information. And like I said, you cannot have correct information without data. So why data? Data is unemotional, and that's the thing I think I love about it so much, because it's not really bothered by opinion. It's not bothered by what people think. It's not bothered by people's feelings. You know, it's black and white information on paper. It is what it is. And what I love is that it's a clear reflection on the current state of things. We get to see what is currently happening in our organizations, in our designs, on the construction site, etc., etc. Data allows us, firstly, to visualize. Okay, so we get to visualize currently where we're at. We get to visualize the current state of things. We can identify what we're doing well. We can see our successes. We can do more of what we're doing well and less of what we're not doing well. So our shortfalls can be identified and we can navigate those, I would say, a lot better. Secondly, it allows us to take control. I mean, if you see a problem, surely you want to take control of the situation, you want to take control of the problem. So there's the ability to problem solve. We can identify what's going on, and then we can change the direction. We can make informed decisions to align with our goals. We have the ability to back in arguments, and we can predict problems and action change. So if you can see that you're going down a path that is leading you to destruction, if I could use such a big word, we're able to navigate that. We're able to look at that and go, okay, we need to change, we need to action change to steer us back into the direction we need. The last thing it also allows us to do is to strategize. If we don't have all the ingredients, how do we know where we're going? How do we know what direction to go in and what strategies and processes and workflows and all of that to implement to get us there? And then the last thing, it allows us to improve. We can improve lives, we can improve productivity, we can get the results we want, we can make the most of the money we spend, we can value engineer, we can align with goals once we understand the problems and once we've decided to strategize those. and we can measure the outcomes at the end of the day. But data allows us to do that. So now that we've looked at data, and now that we understand that data can essentially help us visualize a problem, take control of the problem, and improve on the problem, the question really is, what data can we get from our BIM models, and where does that take us? So our BIM models contain graphical data, non-graphical data, and documents. And your graphical data is essentially the shell that you see when you look at a design. It is our 3D. Okay, it is our stock standard 3D environment. The 3D model of your design essentially provides the context. Okay, it lets us know where the building is, or what is around it, where is it located. So it gives us a visual reference for what we are designing, for what we're looking to put out there in the world. It gives us location. There's a site, there's a positioning, there's an orientation, there are weather patterns, there's circulation, there's a country that it's based in, there's a city that it's based in. It gives us a location to which to attach data. And then it becomes the placeholder, and this is the important one, it becomes the placeholder for non-graphical data that we will harvest at the end of it. So non-graphical data is essentially the meat on the bones. It's the I in BIM. It's the building information, okay, as such. And I emphasize this because I think at the moment we still live in a society, specifically that I've noticed in South Africa, where BIM is a known concept to those who have embraced it, and those who have embraced it have moved leaps and bounds in the industry. But there's still so many architects, engineers that are still finding themselves outside of this BIM environment. And they think because they're working in 3D, they're working in BIM, and it's not really the case. So your non-graphical data forms the absolute meat on the bones for your graphical data. It is your elements information. It tells you about the elements. A wall is not just a 2D plane where you've got a surface, and those two items together form a wall because there's a thickness attached to it. No, element information now has R values. It tells you the material, it tells you the density, the volume, it tells you how many bricks you can have inside the wall. It tells you so much more, and this information is very important. It gives you manufacturer and supplier information, and it gives you performance information and durability. The last thing is the documentation. So inside our BIM models, we have documentation that gets produced. So we're talking about schedules, cost estimates, consultant, contractor, and subcontractor information, and product documentation. So all of this needs to be produced for a building to be built anyway. But all of this lives inside of our data models. And altogether, these three items form our asset information model. So we have our documentation, our non-graphical data, and the graphical data that lives inside of the common data environment to give us this asset information model. So there's something that I'd like to refer to inward focus BIM versus outward focus BIM. And what I found that is a majority of BIM used today is singularly focused on the building itself, certainly in the context in which we find ourselves at the moment. And what this means is that the building information gets transferred from conceptual design to detailed design to analysis, completes its whole life cycle through to operational maintenance, and then just starts the process again. But what if we actually started plugging into local context? What would that look like? And this is what I'd fondly like to refer to as outward BIM. And what if we started connecting outward? And what if we started plugging into things and using the data that comes from our BIM models for something bigger and something outside of the building itself? What if we started plugging into the urban fabric itself? What if we started plugging into items such as ArcGIS? What more can we do with the data that lives inside of our buildings? Imagine being able to do like analysis on movement around the buildings, through the buildings. Imagine being able to make educated decisions on what to place or what building to place on what site, because we've had a look at the context. We know what the city needs. We know what the city requires. If we've looked at people movements, if we can look at traffic movements, if we can look at the facilities in the area, we can start making decisions about the urban environment that is far greater than just the buildings ourselves, but having the data help inform that process. We could engage in information mapping. We could start analyzing spaces. We can start determining the future plans for cities. There's so many opportunities that exist outside of the building itself when it's plugged into the urban environment. What if we could value engineer items? So looking at the data of a building, we're able to do a little bit of analysis and value engineer our way forward. We can use the data that translate to information. So using the data from our BIM models, we can convert that into information that helps us make better decisions in terms of cost. We can reduce material costs. We can reduce labor costs. We can reduce installation time. And we can essentially have safer sites because we understand how the building is going to work. We understand how facilities are going to be brought onto site. We understand how the disciplines, your different contractor disciplines, engage with the sites, engage with the building during the construction process. And it saves time and reduces RFIs at the end of the day. So what about digital twins? We're able to take our BIM models that come with the data, the 3D design, and the documentation, add to this a whole bunch of wireless sensors, add to this the data integration and analytics, and we're able to provide a digital twin building that can serve both the environment as well as the facilities management team. So this allows us for faster production time. We can build better, we can build quicker. There's more rapid risk assessments that can be conducted. There's real-time remote monitoring. We can learn from our buildings. We can learn how spaces are utilized. We can learn how the building performs, the energy uses, and the list is endless. And it allows us to make better decisions going forward. Again, visualizing, taking control, and improving. So let's talk about data and automation for a second. Now, for somebody whose love language is efficiency, this makes total sense in my life. The idea that we can automate systems and processes and designs and streamline designs based on data and learn from the data and create scripts and generative design algorithms. I mean, it's just, why not? So if we can develop prototypes that we can improve on, we can start automating systems based on the information we receive from our BIM models. We can check for standards compliance. We can automate standards compliance. And for all the architects out there who have to go and jump through hoops for local authority approval because of all the check boxes that needs to get checked, imagine if we can just automate that whole process and get a report that tells us exactly where we're lacking. But the time savings is immense at the end of the day when it comes to automation. And we can just see that right now and how things have changed in the last little while. Just to be able to automatically number doors, automatically number windows, automatically generate basic buildings, automatically generate layouts for buildings, best layouts based on views and location to major routes, etc., etc. It's mind-blowing stuff. But all of that is founded on good data outputs. So I've added in a little video here that speaks quite well to the machine learning and generative design space. It's an Autodesk video, but have a look.
Architecture, being this beautiful intersection of sort of art and science, has two components. We have the creative, intuitive side, and we have the building performance side. As a student, when we went to design school, most designers went to school to study the creativity side of design. Nobody went to architecture school to fill in paperwork.
Today, designers are spending a lot of time manually creating design options. And AI, machine learning, generative design, all these different technologies provide us with the possibility of making that process faster and more efficient. The opportunity to not have to start from scratch again. AI, machine learning, tries to get the computer to learn from past behavior. And in our case, that is data.
So in the context of architecture and engineering, you can start feeding in documents to understand what is contained within those documents and have the machine make decisions for you faster based on the historical context.
Google Maps is actually a really good example of machine learning. You get like traffic, when we should leave, an estimated time, even for a trip that you're trying to take 10 days from now. It'll estimate based off of previous traffic patterns, past data. So if you can imagine your life before Google Maps, we use it and now we can't live without it. It made our lives easier. and made it so that we have a lot more information so that we can make better decisions in the moment. Data is going to be that for design and construction.
In generative design, what you do instead of designing a building in a linear process is you define the boundaries, you define the actual sort of metrics of the building, and within that space you can birth a whole series of different designs and then rank them against each other.
So that customers have the opportunity to see a whole bunch of different design options that can help them quickly narrow down their problem spaces faster.
And this can benefit everybody, not just the designer. If you start building in some of these metrics at the start of your design, then the building owner can start making more informed decisions and understand the outcomes faster. It also helps the environment and benefits when you start building in the understanding of materiality and cost and potentially how far away this material has to travel to get to your site into this algorithm at the outset.
They have outcomes that they want to get to, and they have the data. If you pair that with a generative design approach, then you can have a very powerful system that would be really beneficial in trying to build the optimal solution for their buildings.
Generative design is this beautiful symbiosis between man and machine. You have the human component at the front end making all the decisions and setting what they actually want to get as an outcome. You have them also at the tail end of the process where they evaluate those outcomes from the generative design process and choose the one that best fits. So the context here is AI machine learning is around making decisions from the past. Generative design is around birthing visions of the future. The bottom line here is what we're trying to do really is give more time back to the designer. And so what generative design does is it enables you to build an algorithm that starts to understand both art and science. So all of the boring mundane tasks can start being taken away by the machine. Things around compliance, does the fire egress drawings work correctly? Is my building going to stand up? All of these different kind of things a machine can actually do very, very well. And this is what we want to shift using generative design and AI ML. We want to have humans doing what is really good for humans and the things that we enjoy doing from a design perspective and take away some of the grunt work or the mundane work.
Thinking about smart cities and with the theme of the conference being Smart Cities in 2030, BIM forms the context. And I think I have made mention to this earlier on my talk, but without some kind of physical context, sensor data is essentially useless. We need to know where the sensor data is reading from. We need to know the location. What context is it filling itself in? And BIM data directly forms the context for all of that information. BIM data also allows us, along with the sensor values, to manage the internal environment by connecting sensors to BIM elements. We can monitor equipment inside of buildings. We can schedule maintenance further. We can know when certain elements of the building are starting to pack up and are starting to break. We have sensors that can monitor people flow. We can see which spaces are being utilized. We can manage how the people flow works around the building and inside the building, what the heat loads are. We're able to also, over a year period, gather data as to when the most money will be spent on heating and cooling and when less money is spent on heating and cooling. So all of this information, it forms a great part of where we're going in terms of smarter cities and our vision for smarter cities going forward. There's always talk of smart cities, but what exactly is a smart city? A smart city is a technologically modern urban area that uses different types of electronic methods, voice activation methods, and sensors to collect specific data. Information gained from this data are used to manage assets, resources, and services efficiently. In return, that data is used to improve the operations across the city. This includes data collected from citizens, devices, buildings, and assets that is then processed and analyzed to monitor and manage traffic and transportation systems, power plants, utilities, water supply networks, waste, crime detection, information systems, schools, libraries, hospitals, and other community services. It sounds like quite a mouthful, but what it essentially just is this big network of sensors and systems and devices that talk to each other to help make our lives so much better at the end of the day. It's a little bit scary if you think about it, but essentially all this data is meant to work in this little ecosystem that allows us to live optimally. So now what does that look like for us? I mean, currently I know that Google Maps has been great in telling me and knowing exactly where I'm going on each day. So it has already identified that on Mondays, Wednesdays, and Fridays, I go straight from my home to a specific location, the client's offices, and on Tuesdays and Thursdays, I make my way through to my office where I work in Durban. And every morning, it tells me exactly where I'm going and how long it's going to take me to get there. And I find that pretty cool. Now, let's couple that, for instance, with data drawn from these specific routes that I travel to work. If I follow a specific route every single day to work, and the data tells my app on my phone that there's a problem on my route to work, it can notify me and then automatically reroute me along a better route that can get me to the office in pretty much the same amount of time, maybe a little bit more. But then imagine driving up to your parking area, and instead of having to scan yourself in, based on the information contained in sensors in your car and the devices inside your car, it'll notify the sensors in the building complex that you are meant to be there and automatically open the boom gate so that you can drive into the parking area. After that, you can park. Imagine having to, instead of walking in and pressing buttons, which we all don't want to do right now with COVID on elevators, the devices on you have already told the sensors in the elevator where you work, and in turn, without having to press any buttons, automatically directs you to the 5th floor because that is where your place of work is. Walking out of the elevator, you walk straight to your office, the door opens automatically, again, based on the sensor information and that is located on your device, your wrist, whatever it is on you, the sensors that you carry with you, you're able to walk into your office because the sensors and the data and the information with that knows where you have to be and that you have to be there. And the benefits of that speak for themselves. You won't have people in places that they shouldn't be. The safety elements of that just speaks for itself. But this is the beauty of where we're going, and this is where the BIM data is informing all of this going forward. So I guess this is the point in the talk where we start going, okay, great, we've heard about all the great things about BIM and data and BIM data and how the one informs the other and how it plugs into the wider context and inward BIM and outward BIM, but now what? What are the practical steps we can take? Because I know that a lot of you are still in the space where you're still just coming to grips with what successful BIM looks like, the collaborating on sites, the working with peers, work sharing. How do we align what we've learned today? How do we work with data so that it pays off in the future? And here's the thing. Inevitably, it's going to be two things. It's going to be slowly and it's going to be intentionally. Okay, we have to be intentional about the changes we make in our organization. And if you want to go where you've never been, you got to do what you've never done. So it is going to require a little bit of a shift in the way we do things in the day-to-day. But again, let me repeat, the keywords are slowly and intentionally. Okay, because small, consistent steps in the right direction add up to large, measurable results. If we want to integrate good data standards and work with data and harvest good data from our models, there's a couple of things that we have to just be aware of. And it's small things that we can do to make a big difference in the long run. So the first thing we can do is understand that with BIM, data in equals data out, good or bad. If you put really rubbish data in, you're going to harvest really rubbish data at the end of the day. You can't put bad data in and expect your software to perform some kind of magic and give you good results. Okay, and bad data looks a lot like this. It's duplicate data. It's data that is missing. It's inaccurate data. It's incorrect data. My pet peeve in industry is when I go into firms and I assess their Revit models, and I mention Revit because that's my tool and that's my specialty, but I look at the naming structures of what is inside some of these models, and when a wall is called concrete wall 1 or concrete wall 01 copy 1, that's my favorite. Concrete wall copy 1 copy 1 copy 1 2. It's next level, guys, and it's not the kind of stuff that's going to serve you in the long run. So the first thing to do without a doubt is ensure that from LOD 100 to LOD 500 or LOI 100 to LOI 5 or 600, wherever it ends up, that we're plugging in the correct information in the correct time. And another thing to consider is that we don't go too far too fast. So instead of going, okay, we know that these taps are going to be specified, they are going to be Hansgrohe taps, and we specify everything. So for construction phase, it's there. It's not necessary. It's about as necessary as creating layers and walls at conceptual stage. So create your data in a smart way, input your data in a smart way as you go through the life cycle of the project. The point I'd like to make is to invest in good data systems and data processes, such as good naming conventions. So the following slide shows a project that I've been working on over the last year and some bit. And the one thing that I really loved about working on this project is that the idea of correct naming conventions has taken priority in this project. So it hasn't just been for the sake of having structured naming conventions just for the sake of. The reality is that all of these elements inside this project have to connect through to a facilities management system, which allows them to track maintenance and manage the environment more successfully. The naming conventions are generated. So when we see the GFHTCC13, it's not just random. We look at the breakdown of this, and GF refers to your ground floor, H refers to zone H on the ground floor, TCC refers to the department in zone H on the ground floor, and then in that department, it's referring to room 13. Similarly, in a separate application, we have a supply air system over here with a air terminal that we've selected, and the air terminal also has a naming structure that supports its location and its use. So in this instance, we can see that there's 02WSA171262, which seems pretty random and a little bit complicated, but if you break it down, it's actually pretty simple. We have level 2, we have the west wing. It's supply air 17, so it's mechanical supply air 17, that's the system it equates to. It's in room 126 and it's unit number 2. So having these elements where you have these data structures that allows you to pull back to location, and it doesn't matter where you find this element. When you see the naming code, you know exactly where it's located. When you look at the location, you know exactly what the naming code needs to be. It's a two-way system, and it allows us to plug into a wider network quite successfully because there's a standard structure attached to it. Kind of similar to what we're doing with ISO 19650 on construction sites right now. So the next point I'd like to make is to learn to visualize your project data. Now, if you've worked with me, or if I've had the privilege of working with you in any point of time, you would know that I'm the schedule girl, okay? I love schedules. And the reason I love schedules so much is that they're able to give you an insight to your model that you wouldn't see just by looking at it. So whenever we do health checks and whenever we check if models are behaving correctly or performing as they should, or avoiding clashes and all of that kind of stuff, I draw a schedule, or I create a schedule for it, because a schedule will tell me what the data says, and the data will tell me if the model is accurate. So if we're working in a product such as Revit, for instance, I'm able to draw my schedules, and when I scan through them, I'm able to see what the numbers are saying to me. Now, to anybody that might not mean much, but if you think about it, if I go through this example, for instance, I'm able to see here that a wall is 5 mils short of the level that it needs to be on. So maybe this is correct. Maybe it's perfectly fine. Maybe that's the way it should be. Maybe there's a reason for it. But it's not likely that there's a reason for it. And this could probably be a mistake. The thing is, if you consider that all this data that you are generating from these schedules and from these models, if you consider that they equate to costs, and they equate to quantities, it's quite important that your data be correct. if another consultant is going to be working with your model, if another consultant is going to be generating information from your model. So this is the instance with the wall schedule, which is for the most part a little bit insignificant in this instance. But if you think about door sizes, window sizes, if you're thinking of your glazing schedules, like that's kind of information, that's the kind of stuff you have to get right. And the smallest thing, like allowing for a 900 door when it's actually a 950 door, you know, it's really something that needs to be considered. You're not going to pick that up straight away looking at a model. It's not something that is evident. But if we generate a schedule and we look at the data, we are able to see a whole different side of the story, which is very important for us going forward. This is another tool I've come to love and appreciate in recent months, is PowerVR. And what PowerVR does so well is it graphically represents the story of the data inside your model. So you can plug your model data into Microsoft PowerVR and draw analytics from it. You can determine cost spaces, you can look at occupation levels, you can do energy analyses, and I mean, it doesn't do it for you, it just reads what the model is outputting for you. So I can highly recommend the PowerVR, you know, form part of your data analysis process in a sense. Another thing PowerVR does quite easily actually is if you're running your model checker reports in Revit, and I'm not sure how this equates to all the other softwares, but for Revit specifically, if you plug your model checker information into PowerVR, you're able to generate your performance, your model performance statistics. So in this instance, we can see that the red shows us all the areas that are problematic. We have 550 in-place families. That's an exorbitant amount of families. We can see that the file size is getting a little bit ridiculous. We've got warnings are okay. And also looking at links, work sets, and all of that. So it tells a story, again, that you're not going to be able to see. And again, this is the part where I'm going to make reference to why I say that data is almost like the new 3D, and like designing with data in mind will change the way we look at things and change the way the outcomes look at the end of the day. Project postmortems. I don't know why people don't do this more often, and I know there's a time constraint to all of these kind of things, but looking back at a project and analyzing what you're left with and all the data you're left with from a specific project, it's gold for anybody going forward. So just by looking at the outputs from our models, we can ask questions like, what could we have done better? Where could we have saved money? How could we do things quicker? Where did we lose most of our time? Where were most of our on-site issues? Was there something we could have predicted with these issues? Could we have avoided these issues if we considered the correct outputs and data? What can we learn from the things we did well? What can we do from the things we didn't do so well? So bottom line, how can we improve? If we've designed a hotel project and we know that this thing went over budget and the time extended, and usually there are reasons for that which are just unavoidable in terms of contractors and clients and all of that. But what could we have done in our power to have made this process better? I'm currently working with a client who is investing in time management, or taking their BIM data, merging it with time management, and tracking times on projects a little bit better. That is valuable to any organization, because if we can save time, we can make money and we can make profits and be more profitable on projects than ever before. But most of all, I believe that we need to learn. Learn from data, learn about how to manage data more efficiently. It forms the foundation of everything we are stepping into. And let's be honest, data is not just limited to BIM and construction and smart cities. Data is linked to everything we do. Data is in our budgets. Data is in the way we spend money. Data is in the way we drive. Data is essentially in the way we live. But if we can harvest that data, we can have sound information to make better decisions off going forward. better decisions for your business, better decision for your organization, better decision for you personally. There's just so much to be gained from this world that we live in. And with everything moving in the direction of data and connectivity, it's beyond beneficial to understand how data works and data structures work. I just want to thank you all for taking the time to join the session. Yeah, I appreciate the time, and yeah, I really hope that you managed to take something away from this. I know we're all in very different stages when it comes to this idea of data, and I know some of you might be listening to this and say, yeah, Ben, they've done that, and some of you might be listening to this going, we're not even near there, and that's okay. But I'm hoping that today's talk has at least been informative in some way, and I hope it's provided some practical steps to move you in the direction of better BIM and better data management. Thank you.